folks. Welcome to
Vector Calculus.
Alright folks, so welcome back to the next vector calculus lecture. Today we're going to check out how to actually plot a hyperbola. Alright, so let me go ahead and write down the equation we're taking a look at today. So today we have 4x squared minus y squared is equal to 16. Now we actually have to find out the foci, the vertices, and the center of this graph. So how do we go ahead and do that? Well, to answer that question, the first thing I'm going to do is take a look at the standard form of a hyperbola. And what is that standard form? Well, let me go ahead and refresh your memory. The standard form of a hyperbola is going to look almost exactly like the standard form for an ellipse, right? You're going to have x minus h squared and y minus k squared on the top. Remember, it's very much like a circle. Ellipse is exactly the same for a circle as a circle, except your denominators are going to be different. Except the only difference between an ellipse and a hyperbola is this plus sign, right? So for an ellipse you have a plus sign, right? And that signifies that you have an ellipse. On the other hand, a negative sign signifies you have a hyperbola. And all of this is going to equal 1. So if that's the standard form of a hyperbola, our goal is to get this general form of this hyperbola to this standard form, okay? To the standard form. That's our goal. So how do we go ahead and do that? Well, by now you probably know that these kinds of problems require a special tool called completing the square. So let's go ahead and do it. Let's complete the square. Who's ready to complete the square? Raise your hands. Okay, wow, we have one hand raised. Okay, so let's go ahead and raise our hands, okay? So, first thing I'm going to do, let's go ahead and write this down. 4x squared minus y squared is equal to 16. First thing I'm going to do is to complete to factor out the square, is just go ahead and divide both sides by 16. I mean, we already have our squares, right? So this should be a no-brainer for us. So let's go ahead, divide both sides, all the terms by 16, so we can get a 1 on the right-hand side. Who likes the number 1? Raise your hand if you like the number 1. Yes, okay. So now what do we end up with? Well, on the left-hand side, we end up with x squared over 4 minus y squared over 16 is equal to, well, what's 16 over 16? What's 16 over 16? Who knows what 16 over 16 is? Yes?
It's 1.
And what about 1? Everyone knows it's 1. Okay, good job, good job. Okay, so we've just got from the general equation, from the general form to standard form. Okay, so now we got it in standard form. What's the point? What's the benefit of having done this, all this crap? Well, the benefit is actually we know the foci, the vertices, and the center just from this standard form. So let me go ahead and show you how we know that. First and foremost, we know our a value from this, right? What's going to be our a value? Well, our a value, unlike an ellipse, there's no relation. There's nothing that says a always has to be greater than b. That's only true for an ellipse. For a hyperbola, a is just the term under the first number, right? Under the first variable. So in this case, we have a squared. We have a squared is equal to 4. And if a squared is equal to 4, well, then you know a must be 2, right? Likewise, we can deduce what b is. We can deduce what b is, okay? We see that we have b squared is 16. Well, if b squared is 16, it's pretty easy to find out what b is, right? If b squared is 16, then b must be 4, ladies and gentlemen. B must be 4. And finally, do we have a horizontal or a vertical parabola? Well, to answer that question, let's go ahead and take a look at the two types we have. If we have a horizontal parabola, we'd have our x squared term as positive. If we have a vertical parabola, we'd have our x squared term as negative. So let me go ahead and illustrate to you what I mean, okay? So let's go ahead and, okay, so here we have a kind of a basic parabola, or a hyperbola rather. And let's say we have our x squared term negative as we do in this case. So if the x squared term is negative, we have a vertical parabola, hyperbola, as you can very clearly see from the picture that I just undid. Okay, so as you can see, we have a kind of vertical hyperbola, and this vertical hyperbola has our x term as negative. So since over here, look at the signs over here. What do the signs tell you? Well, the signs tell you a lot. Here the y term is negative, telling you that we have a horizontal hyperbola. So indeed, our answer is going to look very much like this, okay? So that tells us a lot. First and foremost, what do we know? Well, we know our a and b values. That's a lot to know. And we also know our c value. Okay, for a hyperbola, remember that c squared is equal to a squared plus b squared. And so c squared has to equal, what's a squared? Well, it's 4. Plus what's b squared? Well, it's 16. So c squared is 20. And so if c squared is 20, we know what c is. We know what c is, ladies and gentlemen. So c must be the square root of 20. Or well, you can also call it 2 root 5, your preference. So if we know what a, b, and c all are, we can go ahead and actually find the vertices, foci, and center of our hyperbola. So let's go ahead and do that, okay? So first and foremost, what I'm going to do is draw a quick sketch of our hyperbola, okay? Let's come over here to the right-hand side. Who likes the right-hand side? Okay, who likes the right-hand side? Nice, nice. Right-handeders, okay. So let's go ahead and draw a quick sketch of our hyperbola. Quick sketch of our hyperbola. So here is our hyperbola, as you can very clearly see. Now, what do we know about our hyperbola? Well, number one, we can very quickly deduce what its center is going to be, right? What's the center? What's the center of any hyperbola? Well, remember the center is going to be given by h comma k. H comma k. Who likes h and k? Okay, very nice, very nice. So h comma k. So what's our h comma k for this case? Well, in this case, you can very clearly see we don't have any h and k. So our h and k are going to be 0 comma 0, also known as the origin, ladies and gentlemen, also known as the origin. Okay, well, that being said, how can we now find the actual vertices, of our ellipse? Okay, finding the vertices, it turns out, is no hard matter. Because remember, the distance from the center of our hyperbola to the vertex is given by what? What variable represents the distance from the center to the vertex? Well, that's going to be a. It's going to be a, right? So if that distance right there is a, and we know a is 2, then well, it's pretty obvious what our first vertex is going to be. It's going to be 2, or rather negative 2 comma 0. Likewise, this vertex is going to be 2 comma 0. And now we can pretty easily figure out what our focus is going to be, what our foci are going to be. Okay, remember the foci are kind of located within the actual cusps of our hyperbola. Okay, so imagine that we have a foci here and a foci here, okay? So, ladies and gentlemen, what is our first foci going to be? Well, that's going to be where? That's going to be at, remember, it's going to be a distance of c units away from our center. So we're going to have 2 root 5 comma 0 and negative 2 root 5 comma 0, okay? So those are going to be respectively the foci of our hyperbola. And now we're almost there, ladies and gentlemen. Now we're almost there. The only thing remaining for us to do is actually sketch the asymptotes of this hyperbola. Asymptotes, okay? My favorite word in the English language. Who likes asymptotes? Okay.
I don't even know what it means.
Me either. Okay. So, first thing we're going to do is actually sketch the asymptotes of this hyperbola. So, let's go ahead and do that. First and foremost, we need our coordinate plane, right? So, let's go ahead and sketch a really quick coordinate plane right here. Now, we know the center of our hyperbola. We already know that it's going to be 0 comma 0. That's right there. Okay, as a matter of fact, I can go ahead and zoom in, so this is better. So let's go ahead and sketch the center of our hyperbola really quick. That's going to represent the center of our hyperbola. Okay, and even further, let's go ahead and sketch the center in this fat blue color. Okay, so that's going to be the center of our hyperbola. Now, if we know that's the center of our hyperbola, how do we actually sketch the asymptotes of our hyperbola? Well, to sketch the asymptotes of our hyperbola, remember we need only 2 values, a and b. And we know both of those values. What's our a value? Well, our a value is going to be 2, right? As you can see, our a value right here, there is going to be 2. So if our a value is 2, we can very quickly sketch out our rectangle, right? So our a value is 2. So let's go ahead and sketch that out. So we're going to go vertically a, or are we going to go horizontally a? Well, remember, a is going to be this way because we have a horizontal parabola in this hyperbola in this case. So that's our a value, right? We're going to go 2 to the right and 2 to the left. That's our a value. What about our b value, ladies and gentlemen? What about our b value? Well, b value, we're gonna go 4 units up, 4 units up, and 4 units down. Okay, 4 units down. Okay, and let's go ahead and put that down. So 4 units up, 4 units down. And ladies and gentlemen, we almost have our rectangle. We almost have our rectangles. Who here likes rectangles?
I like a circle more.
Oh, that's unfortunate. Actually, you can go ahead and watch our conic sections lecture on circles. That was lecture number 5, I think. Okay, so we have our rectangle, very crudely drawn, but nevertheless a rectangle. And now we're going to actually sketch the asymptotes by connecting the corners of this rectangle. Okay, who likes corners? Who likes corners? Wow, we have some hands in the classroom. Okay, so let's go ahead and connect this corner and this corner of the hyperbola first. Okay, so boom, that's one corner. Let's go ahead and connect this corner. Whoops, another fail. This corner and this corner. Boom, whoops. Let's see if I can get this right. And boom, we've got both asymptotes of the hyperbola. What are the slopes of the asymptotes, you might ask? What are the equations of these asymptotes? Well, it's actually not too bad, ladies and gentlemen. Remember, we have our rise over run over here, okay? Rise over run. So that's just going to be, for this asymptote, it's going to be y equals 2x, because we have 4 over 2. And likewise, for the other hyperbola, it's almost going to be y equals 2x. But since it has a negative slope, we're going to say it's y equals minus 2x. And now we're almost there, ladies and gentlemen. Now we're almost there. Okay, now it's just up to us to sketch the hyperbola. So, whoa! That's going to be the right branch of our hyperbola. Let's see if we can get this right. Okay, let me employ my highlighter. So, boom, and that's the right branch. And kaboom, that's our left branch. Let's try that again. And that is almost there. And there we go, the 2 branches of our hyperbola, ladies and gentlemen. Now, we have to put our essential things, What are the essential things of every hyperbola, okay? Whoops, I think I got both branches wrong. So let me go ahead and make sure that their center axis of symmetry lies on the actual x-axis. Okay, there we go. There is our 2 hyperbolas. And now what I'm going to do, whoops, let's go ahead and, there we go. Because this, remember that this over here is supposed to be the actual vertices of both parabolas, hyperbolas. Okay, so let's try to get that right next time. Let's try to get that right. This is like my 4th attempt. As you can see, I'm not the best artist. Whoa. 5th attempt. Whoa. Okay, there we go. That's a respectable attempt. That's a respectable attempt right there. Respectable attempt. And right here. Okay, so as you notice, we have number 1, our vertices right here. Okay, that's gonna be at where's the first vertex? Well, that's gonna be at 2, 0. Where's the second vertex? Minus 2, 0. What about our center? Well, as you can see very clearly, our center is at the origin. Okay, and of course, remember, don't forget your foci. Okay, our first focus is going to be at 2 root 5 comma 0, and our second focus is going to be at negative 2 root 5 comma 0, negative 2 root 5 comma 0. And let's go ahead and check if I actually did this right. Okay, ladies and gentlemen, and that's about it. Now, before you quit this video, the final thing we're going to do is check if we're actually right. Okay, so let's go ahead and put our hyperbola in, delete all this crap. Okay, and let's go ahead and put that in. Let's go ahead and put in 4x squared minus y squared. So minus y squared is equal to 16. Let's see what kind of a graph we get. And as you can see very clearly, it's going to be a horizontal hyperbola. Okay, are we in projector mode? Hope we are, because this is absolutely amazing. Okay, so this right here is gonna be, that's gonna be our horizontal hyperbola, ladies and gentlemen. As you can see, you can confirm we got the vertices correct. You can even confirm we got the center of the hyperbola correct. All right, ladies and gentlemen, that's it for lecture 13 of vector calculus, and we'll check you out next time.